I'm delighted to have you here today to this ms.ai chat.
It's great to be here, Nancy. Thank you for inviting me.
Thank you so much. Victoria, you are a neuroscientist. You have a PhD from Cambridge, and you are running Microsoft Partner Channel business for Central and Eastern Europe. And I'm very excited about your background because as we work on artificial intelligence, neuroscience is an important aspect. Now, to build super intelligent machines, we need to gain a much deeper understanding of our brain. So please tell us, how can neuroscience help us explore our brain, but also how are artificial neural networks working, which is a central piece of that, and how can neuroscience help validate existing AI techniques from your experience?
That's a long question, Nancy, as always. And we could be talking about that for ages. Let me try to give a partial answer to your question, because it's a yin and yang, neuroscience and artificial intelligence, neuroscience, intelligence, artificial intelligence, and neuroscience. So both contribute to the development of each other. So neuroscience, to start off with the basics, is the science that explores the brain, the structure, function of the brain, and it's a multidisciplinary science. It brings together science, biology. It brings technology in order to understand, how the brain works, and it brings arts as well. So it's the collection of multidisciplinary approach. For example, if you go to the Society for Neuroscience, which is a global organization at the conference, you would have more than 50,000 participants. And if one walks through the poster sessions or the speaker series that they have there, you would get from high technology to surgeons, to biologists, to mathematicians, everyone working in the same direction. So, in the context of artificial intelligence, there are two streams of these interactions. The first one is how artificial intelligence can help us expedite our understanding, the studies, for understanding the human brain. Either, be it in an experimental setup, be it in the context of chronic disorders and evolution of disease, or epidemiology. So things that would have taken usually 10 years or even more to understand, they can be modeled, they can be accelerated, and then understanding is in place, a decision can be in place for a solution, for a cure, at the end of the day. So it's a shift going from the descriptive work and analysis that currently we have, or we had even when I did my PhD in the science space, to being more predictive, as in, if this and that is in place, or if we have those conditions and that therapy approach, then that's the next step, to even being more prescriptive in order to manage better the evolution or the cure of a disease, or at the end of the day, on how networks, real biology networks, would be shifted, after the influence of a drug or a therapy. So that's, in a nutshell, the first stream. Now, the second stream is how the biology is helping the modeling of the artificial networks, because in IT terms, the neural network is nothing more than an array of connections that have been inspired by the way that the brain works, and that is a very simplified, simplified approach. So you can say that the biology networks are they can be much more complex. You have the neurons as the units. They connect. They are actually circuits. They're not networks in the brain. They're circuits. It's the flow of information. You have the synapses, and you have in each synapse there could be, the information can stop there. It can give a signal back to the origination. There would be multiple and different models that can be developed. So the bottom line is that the biological networks, the brain, can inspire having multiple neural networks that can then help us have a library, in a way, that we can use for addressing different challenges.
Beautiful. Brilliant. That's a brilliant explanation of a complicated question indeed, in simple terms. Even I understand. That's great. And it's also so important to understand that we are totally underestimating our brain, and there is so much more to do there. And inspiring that through technology is a fantastic quest. I think great times ahead.
Thank you, Nancy.
Thank you, Victoria. It's been a pleasure.